So I will talk something about anomaly detection. So this is one of the maybe most important things for any SREs. So I'm Dong from the Baidu. I'm currently a principal architect in Baidu, and before Baidu, I worked for the Bear Labs and Google for about 50 years. Okay, so this is agenda. As a beginning, I will give a brief introduction of Baidu. So maybe most of us not so familiar with American companies. This is a basic Chinese company. And after that, I will give describe some of the heterogeneous services provided by Baidu and what kind of situation to our SRE team are facing in our daily life. I will select some typical services to show how to do how do we do the anomaly detection, and then finally I will try to introduce a platform. So we named it ARC to generalize the intelligence operation platform to have the more I will give some details on the later page. Okay. So this page is a brief introduction of the Baidu. Baidu is a Nasdaq-listed company, and is well known as China's Google. So the main service, of course, we are doing the search. Besides the generalized web search, we have lots of the vertical categories. For example, we have the image search, and we have the video search, and we have the real-time news search. Besides the search, in China, we also provide lots of the other services. For example, we have the location-based services. Baidu Map is actually one of the most popular maps in the China market. And we have the social and knowledge services. We call it the 贴吧 and 知道. So this is actually Chinese name. Its meaning is about a kind of the forum and the question-answer systems. And we have the online to offline services. So we named the services as 糯米 and 外卖. So basically, they just connect some real-world services such as restaurant and some buy ticket to the online users. And we have the finance and payment services. We call the Baidu Wallet. This is something more clear. And Baidu is also one of the toppest cloud provider in the China market. We have the Baidu Cloud. Totally, Baidu services covers more than 1 billion users in the world. Okay, so this is a brief introduction of the Baidu. After that, let's go back to the technical things. So what is anomaly detection? So in the picture in the above, so the how we do the anomaly detection in theory. So for any online services, we have usually we have a monitor system, and we monitor some metrics, get some value, and we compose all of this timing sequence to compose a curve. For example, this is in this picture, the blue lines stand for the real-time values for some services, and we also have another lines. It's not so obvious. It's just yellow lines or orange lines, something like that. So this is computed by some historical data, and we call this estimate data, or we call it normal data. So we keep our eyes on these two lines, on the gap between these two lines. If the gap is become sudden larger or larger than some normal gaps, so we think, oh, something may be wrong. So we need to get some alarms to the on-call guys to let that guys to see maybe something is wrong and you should do something. So that is anomaly detection in theory. However, we can look the pictures in the bottom part. This is the reality. So maybe I can give some explanation one by one. So in the first picture, you can see this is one of the matrix curves from one our O2O services. You may see there's lots of the huge peaks in this curve. And so the second picture is stands for the 3D value curves for some services. You may say the difference, the problem is the first day's shape is obviously different with the next 2 days. And the third one is just the zoom in picture for the first days in the second picture. So I listed this picture here just to show the anomaly detection is actually very difficult in the reality, not like something we learned from the theory. So how to resolve the anomaly detection in reality? The first idea to appears in our head is maybe we can try to find some typical ones and resolve this problem and extend to others. Then we can get all the problems resolved. So first step, we just try to find some typical ones. Here I have 3 examples. The first one we call the holiday sensitive curves. And the second one we call the very unstable curves. And the third one we call a set of curves, lots of curves. But these curves requiring fully automatic configuration. I will give the detailed explanation one by one. Okay. The first category is called the holiday sensitive curves. So what's its meanings? This category stands for such kind of curves. These curves have a very regular performance in the working days. But if the time becomes a holiday, any holiday, maybe weekend, maybe some big or large holidays, the performance is very unusual or even weird. So the on-call guys will be very frustrated in the holidays to adjust the threshold or something. But even that, usually we get the very bad precision and recall on the alarming rate. In China, there's another 2 factors to make things even worse. The first thing is lots of the China holiday is actually based on the China calendars. So the result is we have no fixed days in the calendar. For example, I have 2 examples here. So for this year, the Spring Festival is in the New Year's days in the Chinese calendars. But in this year, Spring Festival is February 8th. But in the next year, it becomes January 28th. And the Dragon Boat Festival is another important festival in China. In this year, it's June 9th. But in next year, it's May 30th. So this is one thing to make things worse. And another bad thing is after based on our observation, even the different the curves in the different holidays have the different performance, different patterns, different shapes. So that means we cannot use the one kind of the holidays data to do estimation or to do model training to use in another holidays. So all these things, combines all these things. The problem in this category is we lack of the data. We have no enough data to train an effective model to do the very effective estimations for the holidays. So this is a problem. So how to resolve this problem? So a very nature, as a problem is the lack of the data. So the very nature idea is, can we get some data in the similar days so we can get enough data? So how can we know, so what kind of date is similar with another date? So we use the CDF of the daily CDF of the curves to describe the shape of each days. So we just use 1 year's data and do some clusterings on the daily CDF of these curves and get the left pictures. The left pictures clearly show, roughly, we can divide the date in a year into 3 categories: the blue, black, and red. So so far we just can forget the holidays, the weekend, or some normal working days. We just to see the data in either in one of these 3 categories. Okay, after get this conclusion, we do some classification training. We just try to classify every day in the year into one of these categories. We use some feature as some date features, such as whether or not this day is a weekend, or this day is a working day, this day is what kinds of the holiday, is a spring festival, using middle autumn days, all kinds of features. We do a training. So we get a model. So the output of this model is, so if you have a date, we can know so which category this date belongs to. So then we can use data in the same categories to do the estimation. Okay, get this. Then we use some logistic regression based algorithms to estimate the baseline of each days. So you can see the right pictures. This is the most weird days in the 2015. So in that days, in China, there's some very special things happens. So the curves become so weird. The black line in this picture is real value days. In the real is a real value, and the green line is estimated value based on some traditional method, and the blue line is the estimated data used by our new method. So you can see our method is not perfect, but much better than the previous one, and good enough to do the anomaly detection. So this is a solution for the first categories. Okay, so let's go to the second categories. This category we call it very unstable curves. The characteristic of this such kind of curves is the first one characteristic is the lowest value of such kind of curve is about 0, and the second one is there's lots of huge peaks in the huge protrusions in this curve. So the traditional method, if we use some scope to evaluate the value is normal or not, does not work. Because if we use a pretty wide scope, we can get the very very low precisions. But if we make the scope narrow, we got a very low recourse. This is conflict. So this is a problem. I forgot some things. This line is actually from some auto service revenues. Why we have such kind of curves? The reason maybe there are two possible reasons. So one is in the auto, you mean something is sold. So sometimes some goods with very high prices is sold. We got a sudden increased revenues. And another possible reason is market promotion. In the online market, we can do a very short-term promotion. So in that period, the revenue will increase suddenly. So we got such kind of curves. Then how to resolve this problem? Another natural idea is so this is a very unstable one. So we can use some sliding window to make the curves smooth. So we actually tried the sliding windows. Unfortunately, it does not work. Why? So if we use a very narrow sliding windows, because the peak is pretty high and the value is pretty high, so the effort is not good. But if we make the sliding windows wide, maybe the curve becomes smooth, and we can get some alarm of we can detect the anomaly correctly, but the delay is pretty large. So you mean if we in the anomaly detection, the long delay is a very seriously things cannot accept by the SREs. So second way we tried is we use the logarithms. We first use the logarithms, try to make the values not so high, so becomes a relative same with the normal values. After the logarithms, we add the sliding windows. So actually, this is a compound method. We also consider the increasing and decreasing rate of this curve. So this 2 pages show our result. You can see we successfully detect the small drops of the curve, while at the same time we successfully bypass the sudden increase of the value. Okay, this is the second category. And this is a third category. For this category, we are facing another kind of problem. So we know there's an existing algorithm to meet the requirement of the anomaly detection in such kind of curves, but we do not know which specific ones we should use, and also we do not know what kinds of parameters we should set to the algorithms. So and the curves number is so large, so we have no enough bandwidth to do the experiment, to do the testing, to do the debugging for each curves. So how to resolve this issue? So what we we also have some examples for such kind of curves. For example, we'd like to monitor the RPC numbers between two models. We think if the RPC models becomes too large, we think there's something wrong. And we also want to monitor the network transmission amount, say the package or something, on some switch device. So this page shows our solution, our possible ideas. Our solution is actually straightforward. We just use some basic machine learning method to do the algorithm selection. So we use some classification method. What we consider what the feature we are considering includes if the curve is periodically in the long term, and what kind of how curve's stability looks like. It's very, very stable, or just like the second category is very unstable. And the third, maybe another feature includes the difference between the maximum value and the minimum value. So if the curve's variance is huge or small, and also include other kind of features I'm not listed here. After do some training, we think we resolve the algorithm selection issues. So we can get some specific algorithm to each curves. Then the following problem is, so how to set the parameters for the algorithm? Our method is so we just select for each algorithm. We set up a set of the default parameters at the beginning, and to see if it works in the online service. If it works, everyone is good, everyone is happy. But in the most case, it does not work. So our approach is do some automatically adjustment based on the human manually marking result. That means if someone report you missed an alarm, or you mistakenly report alarm, then our system will recognize this wrong things and automatically adjust the parameters. So with time being, the system will work better and better. So far, we have a simple statistical result. So the precision is about 84%. This is actually not good enough for the anomaly detection, but it's very helpful in the troubleshooting, because such kind of curve is not so important in our key results for example the revenue or some things. We just use the result to help the SREs to do the troubleshooting. Okay, so I list some specific result we are manually touched on, and we actually resolve some problem in the practice. But after we did this, we found that the problem we are facing is not become less, but it actually becomes more. So by the time being, we just realized, so the most weakness of such kind of approach, I mean the divide and conquer, to select some specific curves and to try to resolve the problem. The most weakness of such a kind of approach does not scale. So we have no enough people, no enough person to deal with each of the curves and to do the testing, to do the experiment, and to design the details algorithms and to set the parameters for each curves. Just because we have too many heterogeneous services. The services are so different. So the idea by the time is, why we just becomes a team to provide the component only, and let the service SREs to build their own anomaly detection system, use our component. or even beyond this, we can just provide a platform. The service SRE even can contribute us with their own component and share in the different services. So that's the idea in our second phase. After we have such kind of idea, we try to make it into reality. But we found there's so many pain points. For some historical reasons, our algorithm is not so easy to be reused in the code level. The one reason is our different algorithm is written in the different program language. See, some algorithm use C, C++, Java, even other kind of language. So they cannot be used in other systems so easily. The second thing is different algorithms use a different data source. And the different data source have a different format. They also cannot be exchanged so easily. And the third one is the most serious things. The data and algorithm belongs to the different teams, different projects. We found there's lots of the permission issues. So one team cannot access the data from another team. And if we add the permission for some team, this becomes n multiply n problems. It's not, again, it's not a scale. So how to resolve this issue? This is our solution. So we just to build a generalized operation platform as a layer to hidden all the difference and provides the unified interface for all the teams, all the service SRE. We can see these pictures from the right bottom. In this platform, we have IDEs. We have the developer environment. We have the IDE. The SRE can use this theme to build their own operations system, not just limited in the anomaly detection. And they can do the debugging. And we also have some simulators. They can do the testing, and they can do the concept proofing. After all this is done, they can just move their own system to a unified running environments. So we have unified interface can dynamically access all kinds of the data. And most important, we require all the kind of the system or component in this team are written by the single program language. Currently, we use Python. So the different team can share the component, and the code reuse can be much more easier. We use a unified code management to manage all the codes. Okay, there are some details about the system. So this page shows how to contribute or manage the lots of the algorithms. So offline research team. So this is actually the team to develop any specific algorithms in the previous slides. So they can continue to do some research work, and they use all kinds of the offline data. They design the algorithms, and they do some training, and they just do some experiment. If they found some algorithm is useful, they just put the algorithm as a component into the algorithm libraries. And for the online SRE services, online services SRE team, either they can just select some algorithm from the algorithm library and manually set up the parameters and use on their online product. Or if they found that there's no good or no appropriate algorithm in the library, they can develop their own. After it proves that the algorithm is work for some services, they can also contribute their own algorithms back into the algorithm libraries. So our algorithms library becomes more and more useful. And this page shows how to unify the data. So we have actually lots of the data source, includes TSDB, time sequence DB, and event DB, and some meta DBs. We just use the unify the message bus to make a unified interface for all kinds of components can access all of the data. So you may see, for now, we are not limited in the anomaly detection models. There's other model, for example, the alarm filter and alarm model. So either on-call management platforms can use this data via the single message bus. So we resolve the data-related issues. Finally, I'd like to show a real application developed based on these platforms. I'm sorry there's Chinese characters on this page, just because most of the SR is Chinese native speakers, so Chinese is more friendly to them. So basically, this page shows on-call management console for the Baidu maps. And from this page, we can clearly show how our on-call message is generated, how the message is delivered and delivered to which on-call guys, and what all of the related people in this with this on-call message, and the progress, and when the on-call message is closed. Okay, so this is just the first step. We try to make our own on-call message, or our operation platform is a unified platform. Just because like the companies like Baidu, there's so many services. So we try to use a uniformed platform to manage all kinds of services, all of the services with the lowest effort, lowest cost to get the most efficiency. Okay, that's all for my talks. So, okay, thank you.
We have about 12 minutes for questions. So if you have a question, can you walk up to the mic, please? Did I understand that the language for the platform was Python?
Yeah.
And all your developers were able to operate in that language, or they needed a lot of training?
Yeah. So for the existing algorithms, we need to upgrade it or rewrite it in Python. But for the newly algorithms, we just mandatory requirements. This is just mandatory requirements. So it's written in Python. Yeah.
Thank you. Anybody else?
So I'm with Amazon. We have a huge metrics meeting every
Okay.
week, and we
Yeah.
look at graphs. So we sit down and we look at graphs, and one of the hardest things to do is RCA work, root cause analysis. But I don't mean root cause analysis for catastrophes. I mean root cause analysis for anomalies. So we'll look at a spike, and we'll be like, why is that there? And someone in the back of the room will be like, we were load testing. And someone else would be like, well, why is that spike there? And they're like, it was the World Cup in France. You know, so, and we've tried to make tools that track every change in the organization and line up every change with the spike in the graph, and they just aren't very good. It's difficult to do this without putting a bunch of human eyeballs in front of a bunch of graphs. Have you guys had any luck with this?
Sorry? What,
So, any
maybe
like
I
with
cannot get your question. So,
corresponding anomalies, not necessarily errors, but anomalies with their cause, whether they be human or within the organization.
uh-huh.
And any software that can make these decisions, or is it really only humans that are going to be able to do this in a large org?
I think that it's actually I'm not talking about say root cause analysis. I agree with you. Root cause analysis is a more difficult issue than the general anomaly detection. The detection is just it's a very first step to do things. So in our system, we just want to make the anomaly detection as fully automatic. But yes, to the root cause analysis, we try to do some recommendation for now, but frankly, we do not make it fully automatic so far. Yeah,
Thank you.
thank you.
Thank you. That was a very interesting talk. So you have these algorithms you train, and then sometimes they flag an anomaly, and that goes to the on-call people. When they get that alert, does it also show them like the graph of what is observed and what the model thinks would be normal then, to sort of, so they've got some idea of why the system thinks that's anomalous?
Sorry, can you repeat your question?
So when you were showing us the models, you had these figures with the graphs and the model lines and the observed data.
Yeah.
When your system detects an anomaly, does it provide that feedback to the person who sees that anomaly, the people on the call? Do they get to see those graphs as well?
I'm afraid I'm still not get your question. So what's your
So you've trained this system so that it has an idea of what is anomalous, and that can raise an alert. And so you've got people on call who get those alerts?
Yeah, this is also what the on-call people get to be notified, right?
Yes. So do they get, is one of the outputs not just an alert, but also, if you like, a picture of why the system thinks this is unusual behavior?
I just you mean the on-call message content?
Sure.
Okay, yeah. So this may be related with just now questions. So when the anomaly the system detected, the current system try to include all kinds of the context informations in the alarm messages, and try to make the on-call guys more easily understand what happens. And at the same time, our root cause recommended system will try to recommend it. So some potentially root cause for this anomaly. Although I agree it's not perfect for now, but for now we recommend top 5, the system with top 5. The guys can see this top 5 cause firstly. If they think that it's okay or the second one is good, maybe they try to first see what is happening in the second ones. But of course, it depends on cause quality to do the root cause analysis. Yeah.
Okay, thank you.
Thank you.
These are great questions. Anybody else have any more? Going once. Okay, well, let's give them a round of applause. Thank you so much.
Thank you.